Thanks for coming to day 3 of the developer track. We have an exciting talk here by Jasmine Roberts on Lucid Realities, a glimpse into the current state of generative XR by Microsoft Research. Very looking forward to this. Please take it away, Jasmine.
Okay.
We will be passing the mic around at the end, so just raise your hand if you'd like to ask a question.
Hello? Okay, you can hear me. Okay, so I'm Jasmine, and I'm here to discuss the current state of generative AI and how these advancements can actually parallel our mixed reality, XR, whatever you want to call it, ecosystem. And so I spoke in Portugal, it's been like 8 months, and quite a lot has clearly changed within even just the last 8 months. Okay. And so the reason why I called the talk Lucid Dreams is because I feel like that was the promise that we had of generative AI, right? Which is being able to will things into existence. However, now there's been a lot of experimentation showing that generative AI is highly, highly limited, right? And so we're very familiar with this Gartner hype cycle, and if you're not, this is a cycle a lot of marketers refer to. And so GPT had actually been around since about 2018, 2019, and the Codex, which is the generative coding model, has been around since 2021. So it really didn't gain traction until the second release of DALL-E. So not the first iteration of DALL-E, the second iteration of DALL-E, which was April 2022. And then again, as we know, I think it was November 30th, ChatGPT released, and then all of a sudden there was this really sharp incline. And so now in June, we're sort of in the trough of disillusionment, right? So there's Senate hearings and people are discussing alignment and ethics. And again, this all was foreshadowed by researchers like Dr. Timnit Gebru and colleagues much earlier. And so I think right now we've sort of transitioned from that techno-optimist state to a dystopian state. And both of those are non-ideal. And so I was thinking, okay, how am I going to discuss ethics? I can be very strong politically, so I was like, I won't actually think about what I think about ethics. I'm just going to ask ChatGPT to see how it's aligned, at the moment, anyway.
I believe people may have had unrealistic beliefs about the
Oh, there should be audio.
like me because of media portrayals and exaggerated hype,
Oh.
which can create an exaggerated perception of what AI can achieve. While I can generate impressive outputs in certain tasks, I have limitations in understanding context, common sense reasoning, and complex real-world dynamics. It is crucial to maintain a realistic perspective, collaborate with human expertise, and consider the ethical implications of AI for responsible and beneficial use.
Yeah, so that as of yesterday, that's actually ChatGPT's position on the question that I did ask it. I said, why did it, I was more passionate, couldn't read my passion in text, but I was like, why did people really think that you could solve everything? And that was its response. And so one thing that I always talk about is everyone's wondering, okay, well, why are there so many limitations, right? And then the reason for these limitations are very, very simple. It's data, right? So I think when you kind of frame it, we've only had about 60 years of modern computer programming, right? So the 60s. So we've had art for 30,000 years, right? So when you use Midjourney and DALL-E, you kind of have to be cognizant of that there's thousands of years of imagery to pull from, and we don't have the same in regards to programming or even 3D modeling. Okay. And so there was something that was really funny to me on Twitter where someone was so astonished, right, about that that they were able to prompt ChatGPT and it was able to reproduce a game of Pong. But then to me, I'm just like, well, GPT is pulling data from GitHub, right? And if you do a GitHub search, there are 90K repositories of Pong. So I hope it could reproduce that. It could probably reproduce in whatever language you want. And then it's the same with all those other common Atari games, right? There are 25K breakout repositories on GitHub, and there's 95K Snake repositories on GitHub. So even though it seemed like it was fantastical for some people, it's like you really have to look at why it was easily producible in the first place. And so this is a packed bubble chart of the top 10 languages on GitHub, and you see why this would matter to us as developers. And so if we look at languages that are relevant to us, we're thinking, okay, we need C++ for Unreal and Godot, and we need C# for Unity, and we need JavaScript for WebXR, right? And so we can see that C++ has 10%, JavaScript has about 9.5%, and C# has 3%, right? And what do most developers use when they're doing interactive experiences? Thank you, yeah, C#. C#. And so the thing is, one thing I wanted to note is a lot of the examples that you're seeing online that are getting traction, they're made in JavaScript, right? Because there's a larger amount of data in JavaScript. And then one thing that I mentioned in October that I'll just mention again verbally is that when you're doing C# runtime, you need a runtime compiler, right? You don't necessarily, because there's a difference between a scripted language versus an interpreted language, right? Which means that with JavaScript, OpenAI already gave you the Node.js wrapper, and that's like perfectly available on their GitHub. But if you're trying to use like GPT-3 in C#, what we found to use in research was using something called the Roslyn C# compiler. So that's just something to note. And then as we know, C# and .NET is a bigger language than is just used for Unity alone, right? Because Unity incorporates like very game-specific features. It has its own classes. It's used for managing game objects, mechanics, animations, UI, and it clearly has its own conventions. So even of that 3%, it's even less than that to pull that you'd be able to even use to make anything with Unity. And then I think this is where a lot of people, I think, don't understand that a lot of what they want from generative AI, they could actually get from procedural generation. So procedural generation is the automatic creation of content algorithmically, right? But which means that you have to have a very specific set of parameters, which requires more programming on the developer's end, whereas generative AI, it's autonomously creating new and original content, right? Like we've seen images, we've seen music, we've seen text, and it learns these patterns and it generates output based on patterns. And so this was something that, oh, it should be playing. Well, this is the procedural content generator that Epic Games released only a few months ago at GDC. Oh, can someone press play? Oh, no. Okay, let's just keep it moving. Okay. We'll keep it moving. Okay, and so this is one thing that was actually done not at Microsoft, but at Google. And so one thing that we did when we were looking at the depth API, we were actually inspired by the Minecraft AR. So we were thinking, okay, if we want to create clones of objects, how can we do that easy in AR? And so this is just like a mock-up of what it looks like, but it's on GitHub right now. And it's just, the intention of it was to just be able to replace those dominoes with environmental assets, right? So you can replace those dominoes with trees, whatever, to quickly sort of make an AR type environment. And again, it's a lot of the stuff that I do is open source. Fortunately, I've been able to do that even within the confines of companies. And so that is publicly available. And so I wanted to sort of just, okay, this is a table about the advantages of procedural generation versus generative AI. And I think maybe to sum this up, because I do want questions at the end. To sum it up, I would use procedural generation for environmental creation, and I would use generative AI to sort of introduce elements of surprise in games, right? Because the thing is, there are some situations where you need bespoke assets, so generative AI really wouldn't cut it. But then also, one thing that we found during gameplay, generative AI is really interesting to introduce because, one thing that's interesting about games is like introducing just like components that are not even readily understood or anticipated by users. So that's what we ended up doing, and I'll show that later. Okay, and so this is me just putting it out there. We've seen this example over and over and over ad nauseum, so I'm gonna tell you how like it was done really quickly, because then there's more stuff after this. So this was the Blockade Labs example, and they were basically making a skybox using in-painting and out-painting. So let's get into that. So if you generate something with DALL-E or Midjourney, it generates a square image of like, I think it's 1024 by 1024. And so out-painting is when you generate additional content beyond the boundaries of an existing image. So I'm able to get a sort of 2x1 panorama, right? And so out-painting is to extend an image, right? And then for in-painting, on the other hand, involves filling in missing information or even being able to change information within the bounds, right? So it can reconstruct it could visually reconstruct information within the bounds. And so what Blockade Labs did is they took that sort of 2x1 panorama image, or you could actually stitch it so that it makes a cube map, and then they just mapped that onto there. And so again, I have an implementation of this on GitHub where I integrated Dolly into Unity, and then from there I have one example scene that's called Skybox. So you can use it. I'm not getting paid for it, but it's just something to have. And so another thing I wanted to talk about, because I think this has shifted to what the grand savior of XR is, but I'm going to explain the limitation. So NERFs are very popular. And so NERF stands for Neural Radiance Fields for View Synthesis. And they were made by researchers at Berkeley and UC San Diego. And they have many applications, quite obviously. And so it allows us to create immersive content where we can see objects and scenes from different angles. And basically, it reconstructs and renders realistic images of scenes and objects that were not explicitly captured in training data, because it's taking the distance and also like the lighting data from a variety of points so that it could extrapolate missing data. But I think the problem with NERFs, which I think people are finally realizing, is that when we're talking about game programming, we need meshes, right? And so meshes are the fundamental representation that we use, right? And the reason why we use meshes is because they're structured, because they efficiently render, because they have a level of detail capabilities, because I can use collision detection, right? Because it's interoperable, because there's a level of artistic control. And so to sum it up, this is kind of, if I had to give a one-sentence answer of like, okay, well, what's a NERF? I would say it's a frozen point cloud. And this is from Luma, and I would go to their talk, I think it's after this. And then I would say that a mesh is more so a network surface representation. So again, a point cloud doesn't have these sort of, these polygonal structures that allow me to manipulate and deform things. But I would say the advantage of a NERF is if you're looking for appearance and visual fidelity. And so what we're having to do now is you have to basically take a NERF static representation, and then you have to basically do an algorithm, usually a marching cubes or marching tetrahedral algorithm, to convert the NERF into a mesh in the first place so that you're able to do the deformations. And so this is a walkthrough. I hope the person who wrote this isn't in this room. Nope, good. Okay. So this is something, so I posted like the NERFs research that we had done. And you know how there's always reply guys? Well, this reply guy, I had to answer him. So he said, like he wanted it to be, he basically wanted the NERF to be able to, he wanted the body to be a NERF, a full NERF representation. You're able to sort of walk up to an object, it's able to sort of infer the properties of that object and then do the appropriate interaction with said object, right? And actually, this is my friend, so that's why I kind of wanted him to be here. I'm teasing him. He's a really good UX designer. But the problem with that is you have to think about, okay, well, if I wanted to be able to do something like that, I would need to know so many different properties, right? So first of all, my hand in that situation would be the blade. And then I would think, okay, well, I have to cut an object, right? And like, what object is that? And then I need to know, okay, well, what's the cutting board? Is it wood? Is it plastic? What is it? And then there's also the surface of the table. And so I think what the answer is, all of those material properties that you see, like tensile strength, ductility, elasticity, friction, thermal conductivity, where is GPT going to get that information, right? Where is it going to get? Material scientists, maybe, but it doesn't have that information embedded in it in the first place. Oh, yeah. So I decided...
You want to know a big secret?
Hold on.
Tell me.
The cucumber does nothing. This is something we make up.
I love that clip. Okay, so basically I decided to say, like, okay, if you wanted to cut and slice cucumbers, like, how would you do that? And this looks really, really rough. But so if you're trying to generate a 3D model from a point cloud, what you would have to do first is put that into, this is in point E. I would say that Dream Fusion probably has higher fidelity. I don't know if I'm allowed to say that, but I did. Oops. Can you edit that out? but point E is OpenAI's solution of making a point cloud model. And so if I type in cucumbers, that's what it outputs. It outputs a point cloud of a bunch of cucumbers. I mean, at the very least, you're able to get the sort of structure of a cucumber. I mean, I don't know if you saw that, what would you think? It kind of looks like a bell pepper. I don't know. And then from that, you have to convert that to a mesh. This is just actually the most famous way to convert a point cloud to a mesh. Usually if you take computer graphics, they make you implement this. So it's called like a Poisson Resurfacing algorithm, so Poisson like the fish. And then, yeah, I think it was actually made by researchers at Microsoft in 2006, I think. And so this is how you would do that. It's just an algorithm that takes points and then is able to interpolate to make points. And so then I actually did ask it. I gave it more context in this. I said, if I wanted to use the Leap Motion SDK and have my hand as a blade, like what would I do, right? And so basically what it's doing is it's checking to see if we have the Leap service provider. For some reason, it's somehow making a variable called pinch strength, but I don't understand how a pinch strength at all correlates to me like chopping a cucumber. So that's red flag number 1. I would say that red flag number 2 is there's also this thing at the end where once you collide with the cucumber and you hit the correct position, it destroys the original object, right? But that's kind of not what we want. When you have a cutting animation, you need to see the cross-sectional area of each one. You also need to see the remnants because then there's no point of cutting it. So the thing is, the whole point of this example was that it doesn't even have the capability to do this. This is the best it could come up with, which to be fair, isn't that bad, right? And I'll just read this out. And so I did ask it again, like, did you know that people thought that you can implement this? And then it's like, no, it basically just reaffirmed like, no, I have limitations. I can't simulate material properties. I would need specialized software, physics simulations, and material science expertise. I can't incorporate real-time data into Unity. And yeah, it basically just reaffirmed that, no, I can't do this. And I think that's the thing is maybe sometimes you should ask it what it can do instead of just use it for your own purposes. And so this is something that it can do, which is the first experiment that we did, which is like, that's the average height of a woman. And what you're able to do is you can type in basically anything, and it's pulling them from Sketchfab. And basically what it's doing is it's calling GPT to ask GPT what are the dimensions of this object. And so any object that you type in, it would actually give you the correct dimension according to like in the real world scale. So meaning, I didn't do this, but if you typed in Eiffel Tower, you wouldn't even be able to see it. So the thing is, if you're thinking, okay, well, what can it do? That's something it can do. It does know the general dimensions of objects, and it can spawn that within the confines and bounds of that. So the second one that we did that I showed before, which is a compromise on the cutting. This was one of the first experiments we did where, okay, that's me and my, the person in my lab. And so what we did was, if you look, I know, because I know that the person on Twitter didn't want us to have to voice changing the hand. But what you do is we voice, okay, change hand into, change paddle into knife, and then change the ball into salmon. And then I think you know what happens if you, let me just wait. If you combine like a knife with salmon, what do you get? I already say. Yeah, so that's something it's able to infer. Yeah, so if you look now, he's asking for a knife. And again, it takes a while because now, yes, you could even see that little break. So then now the hand's a knife. And then when it collides with the salmon, it makes sushi. So that's something that it actually can do, right? Like, which kind of gets back at the introducing elements of surprise bit, which I think is one of the most important bits. And then here, let me try to hurry this up. And then so this might be mean, but I would say that if we were to sum it up, a lucid dream is something where I have full agency. I can will what I want into existence. And generative AI, there's too much noise and there's too many parameters that I actually have no control over to be able to generate what I want. And so if I was to say, okay, what's the state of generative AI? I would say it's Greg on Twitter. You know Greg, he's a great account to follow. And then I would say, like, if I were to lucid dream someone into existence, it wouldn't be him. It would probably be Lenny Kravitz. So I would say that's like a good, a good summary of maybe the capabilities. Yeah, that's it.
We have a little bit of time for questions if anybody wants to raise your hand and couldn't. Shoot.
I feel a little bit bad. I feel a bit bad leaving that up. Here, I'll just go to this one, okay?
Hello.
I kind of feel a little bit guilty, just a little bit.
Hi. Thanks, Rich. Unfortunately, I was just able to catch the tail end of the presentation, but I'm very curious when it comes to accessibility, the ability of generative XR to have interfaces that are just text-based, for example, as opposed to having to operate a very complex 3D engine interface. What have you found there, and what opportunities do you think it holds for enabling more people to get involved in creating XR experiences?
Yeah, I mean, I think, yeah, actually, it's funny because the name of the project formally is Speaking the World into Existence, right? And I know that a lot of people that have the capacity to see sort of, downplay it. And so what we found is for people that don't have the capacity to see, the thing is being able to voice things into existence does give them agency, right? I feel like it's easy to downplay if you have that faculty, right? But if you don't, it was something that we found resonated with people more so. And actually, since then, we integrated, so Azure Cognitive Services also has not just speech to text, but text to speech as well, right? So you're able to have a dialogue with the agent as well. And I think that was the best. I still think that's the best use case. Oh, and I didn't mention before, but you have it, right? So I do have the Clippy demo on the MetaQuest Pro if anyone wants to try it. I mean, it's like talking to ChatGPT, but you're just talking to Clippy instead. And it's, yeah, because I don't think the video really captures the visual fidelity anyway, but you're able to go back and forth with Clippy. So yeah, I think that's something that's very important historically, right, to the lab and especially to people like Jared in particular. So yeah, thanks for asking that question. I think making it multimodal is the answer.
Is there any opportunity for premium access that might come that allows for getting rid of some of the harsh latency that we're seeing for the back and forth? You
mean the latency of the game, or?
Well, as we've been using ChatGPT and some of these AI features, they're balancing with a huge load of so many users trying to use it for free so that they gain users. Is there maybe a market opportunity that is in line that offers a premium access for people building premium content that allows for essentially, getting in front of the line?
Yeah, I mean, I would say that, so I think Microsoft has Microsoft for startups specifically, and I think that the integration with the AI is a bit iffy, but OpenAI does have early developer access and programs, and I think they actually have a thing called Converge, so they're very, I guess, excited about partnering with startups specifically, right? Because that's basically their whole business model now, right? Is being able to integrate. So I guess I would reach out to the Converge Fund, maybe not necessarily about funding, but if you want early access, right, to some of these tools, I think it's best to use them early, and then you can have your own specific account where you're given X number of tokens. So I think that should help facilitate that.
Hey, how's it going?
Hi.
I just have a quick question. I know we've kind of earlier in the slides we characterized AI as sort of heading towards the trough of disillusionment. I wonder sometimes if that's an accurate characterization. I know the Altman hearings have obviously put kind of a dent in its, I guess, its reputation among the general public, but doesn't it still feel like the entire world is sort of still ramping up to the peak of expectations about what AI can do?
I mean, to be honest, yeah, I think that's kind of what I was getting at, which is that a lot of the weird thing about that cycle to me is the reason why it looks that way is because people's expectations are overinflated, right? See, I was going to do this, but I didn't do it, and I'm kind of sad now because I was going to have the diagram and then put Jasmine, and then it was just going to be a flat line, of how I view it, right? And I think that's kind of, I agree. I think people overestimated its capabilities from day one. And I think there are clear ethical concerns that need to be addressed, even how the data is even being tagged, who's doing it. But that's always going to have been a concern. And I think a few days ago I was talking about like discriminative models, which is like, is it a cat or is it a dog? Those have been around for a long time. Those have caused harm too, right? Because there's been a case where it's ID'd the wrong person, and then guess what? That person's the one who's then, convicted of a crime when it was actually someone who looks like them, but not quite. And so it's not like that AI hasn't already had these sort of negative ramifications. I think that this is almost easy to attack in a sense because it had way too much hype. And I don't think people were listening to the voices at the beginning that were saying like it is an LLM, which is a large language model. Because I remember someone was like, oh, AI is just a chat bot. I said, no, that's not what AI is, right? That's not AI. There's AI, there's ML, and then there's deep learning, right? As a subset. I was like, AI, you've already been using it this whole time, right? I was like, an LLM is a large language model, so I would hope that's what it's best at, right? Because it's foraging language-based and text-based data, so that's what it's best at. But again, when people think it can do everything like this, that's the problem, right? Or when people try to think it can displace writers, it can displace, like even just basic classification work, it's not really meant to do that. You still need a human, you still need human oversight. And the weird thing is, I know that both Microsoft and OpenAI do think that as well, but you have to understand that for some people, they want to cut costs, right? And I think that's where bigger companies have to be mindful, because even if you don't intend harm, guess what? If somebody can get someone can cut someone out of the labor process, they're likely going to do it. And that, I think, is sort of the burden that we all live with, right? When you're developing technology. Okay.
Thank you so much for your time. That was excellent, excellent presentation.